Okay, guys, so as promised, I am going to go through the problems with you. We went through a few of those today from lesson 1-2 called Solving Linear Equations. We completed up through, I want to say, maybe 16. I can't remember. So I think I'm going to go ahead and start at number 16. This is lesson 1-2. My battery is a little bit low here today, so hopefully I can get through all of these problems. But if you are viewing and wanting to check your work and you want to find the problem you're looking for, you can continue to scroll through this document to find the numbers. I will make sure that they are numbered so you can find them easily. Number 16, and by the way, if you want to find this page in your book, it was page number 15 is where we were starting. But today, beginning on number 16, that will be on page 16, actually. So the problem is this: negative 4x plus 3x equals 2. Okay, so in algebra, we remember there's a couple of rules that we must always keep in mind, and those are, one, that we are trying to isolate the variable. So in this case, we're looking to isolate x. And then also the golden rule of algebra, which remember, the golden rule of algebra means that whatever I do to one side of my equation, I must do also to the other side. We're always looking for like terms. That's another thing we want to keep in mind. Right now, what we've seen most of is anything that has a variable on it, like perhaps an x term. We're looking to combine those. Let's put the word combine here. And then also our constants, which we talked about, are basically when you see a whole number there, those are constants, or a negative number, so an integer. All right, so let's look at this. So I notice here that I have, excuse me, two x terms. I have a negative 4x plus 3x. And if you want to divide those sections, we've been doing that a little bit in class because last year we learned to do that. And I wanted to remind you how to separate our terms so you know which signs are going with which set of numbers. Okay, so in this case, I have negative 4x plus 3x. I notice that they're both x terms, so I'm simply going to put those together by putting together my negative 4 plus 3. And remember I said when you add numbers with different signs, or you're putting numbers together that are of different signs, excuse me, adding numbers of different signs, you will subtract the numbers and keep the sign of the larger number. So in this case, we have negative 4 and 3. So I'm going to put my numbers together and do 4 minus 3, and I'm going to get 1. And I'm going to take the sign of the larger number, which happens to be the 4 right here. So it's going to be a negative 1x equals 2. Okay, and then we want to isolate the variable. So I notice that we have negative 1 times x, so we're going to undo that with division of our negative 1, because that will give me an x on the left-hand side and a negative 2 on the right-hand side. That is number 16. Number 17, we have 7 equals, move this up a little bit, 5y minus 13 minus y. Okay, so I'm looking now for, I'm going to make that a better 13. There we go. So we're going to put the y terms together. I notice I have a 7 on the left-hand side. I have a minus 13 on the right-hand side. And by the way, I'm going to go ahead and separate my terms here. So I have 5y minus 13 minus y, or 1y. Remember, that's just a 1 in there. Okay, so we want to put our like terms together. I have two y terms here that I want to go ahead and put together. So when I do that, I end up with, I'm going to leave my 7 over here. I always make one change per line. I don't want to do a whole bunch of different things because there's a good chance I might make a mistake and then it's going to be hard to track. So we'll do one change per line until we get really proficient at this. So I have 5y. Basically, you have 5y minus 1y. Well, 5 minus 1 is 4, and their last name is y. I have minus 13 left. I'm going to want to get my constant numbers together, which is this 13, the subtraction of 13 on the right-hand side. So I'm trying to isolate the variable. So it would make sense to me then that I want to get this number on that side so that I can work toward getting my y alone. So let's do that. So right now it's set up as a subtraction of 13. So we do the opposite of subtraction by adding, because when I do that, it's going to give me 0. Negative 13 plus 13 is 0. Remember, I have to add the 13 onto the other side as well, which I have done. So I have 20 equals 4y. I'm trying to isolate y, so I want to undo the multiplication there of 4 by dividing by 4 on both sides, and y is equal to 5. Or 5 is equal to y. It doesn't matter which way you write it. If you want to write it this way, that's fine. But the answer is 5. Let's look at number 18. Number 18, I'm going to put it on this side, is 7m minus 4 minus 9m. Now, this particular one has a lot of things happening, a lot of operation. Well, it's got one operation, basically. Everything's being subtracted, but I see many terms here. I have 4 different terms. First thing I'm going to do is take my green pencil, and I'm going to divide out my categories here. Okay, so I'm separating each term. So I start with 7m, and then I'm subtracting 4, and then I'm subtracting 9m, and then I'm subtracting 36. And all of that is equal to 0. You might think that's odd, but as we work through this, we're going to find out what is the value of m that when I put all of those string of numbers together will actually equal 0. So let's figure out what we have that we can combine. I have 2 m terms here. I have 2 constants here that we're going to put together. So let's go ahead and put together our m terms. I have 7m minus 9m. Now here we have, and I want to write this out down here for just a moment. So I have 7m minus 9m. Now remember, we only look at the coefficients. That's what we're subtracting. M is just their last name. So what is 7 minus 9? Well, remember, on a number line, think of it. If you're at 7, here's 0. If you're at 7 and you are going to be subtracting 9, you should be marching in a direction that's moving toward the negative number. So when you subtract on a number line, you move left. So if I'm at 7, first of all, it's going to take me 7 steps to get to 0, right? So 1, 2, 3, 4, 5, 6, 7. But I have to go 9, so I've got to go 2 more. 1, 2. So where does that lie? Land me? Negative 2. So 7 minus 9 is negative 2m, or negative 2. And then we keep our last name of m on there. Okay, so keep that in mind. So look at the rule here. So when you are subtracting or adding together different signs, if you have different signs you're trying to combine, you subtract the numbers and take the sign of the larger number. In this case, the larger number is 9, and we use the negative sign. Okay, I'm going to erase all that. If you wanted to get notes, you can simply back the video up. Okay, so 7m minus 9m we said is negative 2m. I'm going to put together a negative 4 and minus 36. So think of that. I'm going to, in my mind, think of myself at negative 4 on the number line, and I'm going to march 36 steps away in the left-hand direction, heading like I'm subtracting. And so I would have minus 40. So look what I did. I added the numbers and kept the sign, equals 0. All right, now to undo this, we're going to add 40. You've been doing many problems like this. Once you get it to this part, excuse me, I'm tripping over my own tongue here. Once you get to this point in your problem where you have something with a coefficient with a variable, and then subtracting or adding a term here, you pretty much know what to do. I've watched you with that. That's because we were working on those kind of problems at the end of last year. So what happens when I add 40 to both sides? That zeroes out. I have negative 2m left on the left-hand side and 40 on the right. We have to undo the multiplication of negative 2 by dividing by negative 2. That would give me a 1m, or just an m, and my answer would be negative 20. That's the answer to number 18. Let's look at 19. Number 19, actually there is no 19. I guess I'll back up that thinking. We move to 21. All right, number 21 actually has 2 methods of thought here. So I'm going to show you both ways. You can decide which one of these ways you can, actually let's term that as another way. We won't say it's one way, we'll call it another way. Another one way, and then of course another way. And you decide. Sometimes you're going to probably have to learn as time goes on how and when to use either one of these methods. But for right now, you can choose which one you want to use. So here's the problem. We have -2 being multiplied with this quantity, 2 times z plus 1, inside parentheses, and all of that equals 26. So the first way, and I think a lot of you think in this direction, which is completely fine, you'd say, well, I'm going to distribute that -2, and I'm going to multiply that with 2z. So I kind of look at what I'm multiplying together here, and I have -2 times a +2 is going to give me a -2, plus we have that z on there. So -2 times a +2z is -2z. And then I take this, excuse me, -2, and multiply it with a +1. Now, I want to just point something out while I'm right here, because I think some of you are struggling with this a little bit. We're no longer using like algebraic addition now. And what do I mean by that? That means you're no longer seeing like 2 plus a -3 plus 4 plus a -7, something like that. Okay, you're no longer seeing that. What you're seeing now is 2 minus 3 plus 4 minus 7. You have to just know in your mind that this is a -3. That negative sign, if I were to kind of sort these out, I would have 2 minus 3, which we said is the same as adding a -3. Think about it. If you're adding a -3 on the number line, you're moving in a negative direction. If I subtract 3 on a number line, I'm moving in a negative direction. So they speak the same message, don't they? So let's go back up to the problem. So now I have a -2z, and now I'm going to multiply -2 plus 1, and I'm going to get a -2, because a negative times a positive gives us a negative. We talked all about that in class today as well. Remember the little Pocahontas story that I shared with you? If you can remember that Pocahontas story, remember Chief Powhatan wanted Pocahontas to marry within the Indian tribe that he was overseeing. And in doing that, Pocahontas would marry an Indian. So you have an Indian marrying an Indian. And in Chief Powhatan's mind, that was a positive outcome. However, when she began to fall in love with John Smith, that wasn't such a positive outcome. So now you have an Indian gal marrying outside of her tribe by marrying someone coming from Europe, known as an Englishman, and Chief Powhatan did not like that. So you take an Indian with John Smith, and now you have like maybe 2 different signs, right? And Chief Powhatan considers that more or less of a negative situation. So same signs, positive. Different signs, negative. Okay, and I will keep reminding you of that as well. All right, so here's what we're left with. -2z minus 2 equals 26. Okay, now we're in the format that you guys are very used to seeing, and I'm going to go ahead and just work through this. So I have a -2z equals 28. I'm going to divide by negative. Remember, this is something I did point out today. Always remember that you want to divide, include the sign there as well, so that your z will turn up positive. Your answer might become negative, but your z will be positive. You can't land with a -z. That always needs to be fixed. Okay, so now you have -14 as your answer. Oh, wait a minute. Did I do that right? I did something. Hold on a minute. What did I do wrong here? I can tell that's not right. Let's see what I did. Oh, gracious day. You guys are probably screaming over there, Mrs. Quigley, you didn't multiply correctly. Thank you for catching that. This should be a 4. -2 times +2 is a -4. Okay, so let me fix that error. I'm so sorry, you all. I'm sure that, where's my eraser? Here we go. I'm sure that if you were with me, you would have caught me on that. Let's fix that. -4z. There we go. Be -7. Okay. Sorry about that, guys. Go back and see what I did. Right here is where I made that mistake. I said -2 times +2 was a positive -2. It needs to be a -4. Okay. Now, the other way, let me rewrite the problem, and I want to show you another way of doing this. Remember that to undo multiplication, if I ask you to undo multiplication, you would tell me you're going to use division. Okay, well, look right here. I'm going to put parentheses around this just for a minute. This -2 is being multiplied with this quantity, 2z plus 1. So if I want to undo the multiplication, now remember, I'm trying to get z alone. Right now, it's trapped inside those parentheses. So if I want to get z alone, I'm going to need to divide by the -2, because that's going to get me closer to getting 2z, or getting the z out by itself. So I'm going to divide both sides by -2, because look what happens. -2's cancel out and become 1, which I don't even need to write, but it gets rid of the parentheses where my z is trapped. Okay, now I'm back to that same format that I'm used to seeing. I can subtract 1. And although my problems are looking very different, look up here and compare it to this step. My numbers are completely different, but that's because of the operation I chose to do first in each one of those being different. But look at the end, I end up with the same answer. That's number 21, and you can choose the way you like. Number 23, we have 10 times 5 minus n minus 1 equals 29. Okay, again, on this one, there's a couple schools of thought on this as well. I can distribute here first, which I'm going to need to distribute anyway, but I can distribute first, or I can move this 1 over here. Either way is fine. It doesn't really matter. I am actually going to opt to do my, let's see, I'm going to put the 1 to the other side first, just to kind of lighten the load on my left-hand side. So now I have 10 times 5 minus n equals 30. Now I'm going to do my distributing. I have 50 minus 10n equals 30. You guys need to be checking on me, making sure I'm doing my multiplication correctly. Okay, now look at this. I need to get 2 of these terms together. Which terms? Well, I only have one n term. There's no other n term, so he's alone. But the other 2 happen to be, we have a 50 and a 30. Those are constants, okay? They're numbers without a variable. I need to get those together. Makes the most sense to put my 50 on the other side because I'm trying to isolate n. So the more I can get rid of on this side of my equation, the closer I am to isolating my variable. So let's work towards doing that. So I have 50 over here. So the question becomes, do I subtract 50 or do I add 50? Well, let's try adding 50. Am I getting rid of it? No, that's becoming 100. So I've just put more on the left-hand side. I don't want to do that. I want to get rid of the 50. So if I already have 50, let's just take 50 away. On both sides, of course, because that's what the golden rule of algebra says. So what is left? I have minus 10n, or a negative 10n, equals, look here, different signs. What does Pocahontas' father do or say? Different signs. We subtract the numbers and take the sign of the larger number, which happens to be the 50. So I take the negative sign. I'm trying to isolate n, so I'm going to divide by negative 10, not just 10, but negative 10, because I want it to end up a positive n equals 2. And that is the answer to number 23. Number 24, we have, this is a good one too. I'm hoping that as you guys work through this, that maybe you got a little bit stumped here, but I'd love to see what you guys did to try to figure this one out. So I have a negative sign that's outside my quantity 7 minus 2x. And I have to think to myself, well, what do I want to do with that? Because it's obviously part of the problem. I can't just remove it. I'd like to distribute it, but I'm not sure how to distribute it. So if I asked you if you had to assign a number to that negative out here so that I had something to distribute, what do you suppose it would be? Hopefully some of you are saying that it is a 1. So I'm going to stick a little 1 in there, and we're going to do some distributing here. So negative 1 times a positive 7 is a negative 7. Negative 1 times a negative 2x don't forget that he belongs to the 2. So a negative 1 times a negative 2x is a positive 2x, or it's like adding 2x plus 7 equals negative 7. Now, some of you might have done like I did on this problem on number 23, where you where you added 1 to both sides first. You could have done that up here. You could have subtracted 7 from both sides as well. It doesn't really matter which one of these two ways that you choose to do it, whether you get rid of the 7 there first or you distribute first, does not matter. The good thing is, either way, look at what happened here. I ended up with two constants, which are a negative 7 plus 7. Well, what does that look like? That becomes 0, doesn't it? So really, they cancel out. And I'm left with 2x equals negative 7. I divide both sides by 2, and I end up with x equals negative 7 halves. Now, if you want to move forward in the video, you can. I'm going to stop for a moment and redo this same problem using the other method I talked about, where I'm going to subtract this 7 first and see if we turn out the same way. So let's subtract 7 from both sides. It wipes it out here. I'm going to go ahead and stick that 1 in there as well. Now let's go ahead and do the addition of the two negatives over here, negative 7 minus 7. So think of it, you're on a number line at negative 7, but you're subtracting 7, so you're continuing to march in a negative direction. So we just simply add our numbers together and keep that sign. Just like if you had positive 7 plus positive 7, or 7 plus 7, you'd say, well, that's easy, that's positive 14. Well, the same is true when you're adding two negative numbers together. Okay. Let's look back at the left-hand side. So we're going to go ahead and distribute now at this point. I have negative 7 plus 2x equals negative 14. Now, if you look at this line right here and this line right here, they look very different, don't they? I mean, after all, I have a negative 7 on the right-hand side of my equal sign on the top equation, and down below here, I have a negative 14 on the right-hand side. So obviously, it looks pretty different, but let's watch what happens. So I'm going to add 7 because that will help me in isolating x. I'm getting further and further, or closer and closer to doing that. 2x equals up, different signs. So 14 minus 7 is 7, but I take the sign of the larger one. Oh, now look right here. Looks just like that. Now we finally reached a place where we're the same as we were up top. Same answer. Two different methods. They both work. It doesn't matter which way you go. Just be careful to watch your positive and negative signs. Okay, let's look at the next one, number 26. Number 26, we have 1/2 x plus 2 equals 1. Okay, I have one x term. That's nice. I have two constants here. So I'm going to try to get my constants together. And in my mind, I'm thinking all along, what do I need to do? What step do I need to take so that I can get closer and closer to getting x by itself? And we've seen many problems like this in this format. You guys are pretty good at knowing the first thing I have to do is subtract or add whatever the number is here. In this case, we're going to subtract 2. I'm going to with negative 1 on that side and 1/2 x over here. Okay, now if I ask you to undo the multiplication of 1/2 over here because it's being multiplied with x, if I ask you to undo the multiplication of 1/2, you'd say, oh, well, we divide that. So you would do this. However, I showed you that what we really want to start thinking about, instead of having to do that, watch what happens when I actually do divide 1/2 by 1/2. What actually happens? We do KFC, right? And we end up with 1/2 times 2 over 1. So why can't I, instead of actually having to think about that division, let's just multiply it by the reciprocal right here, because we know that's what it's going to turn out to be if I divide that. Okay, so that becomes 1. Oh, we have to do the same thing over here, Mrs. Quigley, don't forget it. Equals a negative 2 over 1, or a negative 2. And that's the answer to number 26. Number 27, we have, oh, this is going to be a good one. We have 3/2 x minus 2/3 x. Oh, we did this one in class, didn't we? Okay, I'm going to skip this one because we actually did this one in class. Let's go back to number 28. Number 28. And if for some reason you think we didn't do 27 in class, you can let me know when you come back and I'll do it in class for you. But I feel pretty sure we did that one. Let me look here, because I remember doing the LCD of 6. Yeah. Okay. So this problem is 1/5 times k minus 3 equals 3/4. Okay. So the first thing we want to do is multiply by 5/1, because that's going to help us get rid of actually both of our fractions, which will be very nice. The other method would be to multiply by the LCD, but I think I'm going to carry you through this way. So we have, this is going to isolate my fraction, or get rid of it rather, eliminate it, not isolate it. I'm getting sleepy here, I think. All right, so I have k minus 3 equals 15/4. Okay, now I'm going to add 3 to both sides. And I'm going to end up with k equals, and I'm going to right here make this 4/4. So I would have 19/4. No, that's not right. Why do I have 12/4? Let me look here real quick. 3/4. Oh, gracious day. It's not 3. Oh, dear. I'm so sorry, guys. All right, 3 is not 4/4. 3 is what? If we're going to put it over 4, there we go. 12/4. I want to leave it that way so I can put my numerators together. And I end up with 11/31. No, 21. No, 31. I think I gave you guys the wrong answer here. 27. 27. Oh, yeah. No. What did I do here? Made a goof. Oh, okay. All right. Sorry, guys. 27/4. There we go. Okay. 27/4. Okay. I've been on math for a few hours here, and I think my brain's starting to get a little bit checked out. So I do apologize, but the good news is if I can find the mistakes through the process, you can watch me make mistakes. That's not always a bad thing. So let's try to see this as a positive thing, and we will move on to number 29. I have 7/60 equals 5/24 times W plus 11/12. Okay, so I see my terms. I have one W term right here, no other W terms, so I'm not going to have anything there to put together. But I do have two fractions without a variable, so I want to try to get those two together. Now remember, kind of taught you guys a cool way to eliminate our denominators. Yes, I can spend time trying to make common denominators, changing my fractions to equivalent fractions, but quite frankly, the easiest thing to do is to figure out what your LCD is, your lowest common denominator, and then multiply each one of those three terms with it. Well, I happen to know that the common denominator for all three, the least common denominator, is 120. So I am going to multiply, and I'm going to change the color of my pencil for just a moment here. I'm going to multiply each one of these three terms with this lowest common denominator of 120. I got to squeeze it on this side here, and over here I'll put it right here. Now remember, I can cross cancel, so let's start doing that over here. 60 goes into 60 once, and it goes into 120 two times. 24 happens to go into 120 5 times. 12 goes into 120 10 times. So now I'm multiplying it with these three reduced terms. So what do I have left here? I have up top, I have a 2 and a 7. 2 times 7 is 14 equals, and I have 5 up here that I put up at the top, times the 5 that's down here. So I have 25W plus 10 times 11, which is 110. And there's my new equation. Now I have to get W alone. So what do I need to do? First step would be to subtract 110. Look, different signs on the left-hand side. So I'm going to subtract the 2. You can use your calculator for this. Just put in there 110 minus 14. You're going to get 96, and you're going to take the sign of the larger number. We're going to divide by 25 on both sides of our equations, and I'm going to end up with W over 96 over 25. And that's your answer to number 29. Okay, and we're going to do number 30. Number 30, you have 3m over 4 minus m over 12 equals 7/8. Here again, I have 3 denominators. They're all different. Let's figure out the lowest common denominator. But instead of making equivalent fractions, we're going to clear the denominators out by multiplying by that lowest common denominator. So what is our lowest common denominator or least common denominator? However you like to use the L term. It means the same thing. Okay, so the LCD, hopefully you said, is 48. So I'm going to use a different color pen here, and we're going to multiply all 3, oh, look at that, Gators colors, by 48. Okay, so I'm multiplying all 3 of those by 48, but I'm going to do a little bit of reducing first. That's how we clear out those denominators. Okay, so 4 goes into 4 once, goes into 48 12 times. 12 goes into 12 once and into 48 4 times. 8 goes into 8 once and into 48 6 times. So here's what I have left. Let me highlight this for you in yellow. So I have 12 times 3m. I have 4 times m, and I have 6 times 7. Those are the 3 things that we're going to be putting together here. So 12 times 3m is 36m, minus 4 times m, which is 4m, equals 42. Now I have 2 m terms here, don't I? Let's subtract that. 36 minus 4 is 32m. Keep the last name. Equals 42. I'm trying to isolate down to getting m all by its little self. I can do that by dividing both sides by 32. I would end up with 42 over 32, but those are both even numbers, so I know that those can reduce a little bit further. At least we can divide them by 2, and I would get 21 over 16. And that is my final answer. Number 9, I am going to... I think I'm going to leave that and try that in class with you. So if you want to go ahead and check, try that one on your own. Let's just see what you guys come back with. Go back in your notes. I believe we had some of those in our notes, so you can go back and try to find that, see if you can make sense of it, put it together. If not, it's okay. We're going to do it in class together, and I hope this helps, and I will see you all on Thursday. Have a great night, everyone. Bye.